Alright, so in this video we are going to be going over our exponents, and we're going to be going over word problems, as you can tell. So we have 3 word problems here, the first two being a little bit easier and the last one being a little bit more difficult, but we'll go over all of them turn by turn. So let's just start off here. So you want to invest $500 in a savings account. Okay, and that savings account multiplies your initial investment by 1.02 each year. Put simply, how much money will you have after 8 years? So let's say you're, in grade 9 and you have $500, and by the end of university or college, you want to see how much money you'll have, right? Because 4 years of high school and 4 years of university. How can you calculate that? Well, let's see what we have here. We have some sort of initial amount of $500, and we know that that initial amount of $500 is being increased or multiplied each year by a factor of 1.02. Okay, and we also know that, well, we have 8 years, so we want to know how much money we'll have after 8 years. So how can we write that in a mathematical formula? Well, we can think about it kind of logically. We have our $500, it's increasing by 1.02 each year, and we have 8 years. So I have an initial amount of $500, okay? And every single year, that's increasing by 1.02%, or that initial amount is getting multiplied by 1.02. So I can put multiplied by 1.02. But this expression is just going to give me how much money I have if I were to do this only once. So whatever I get here, I've now earned it one time, and that's it. But this isn't just happening one time, it's happening multiple times. It's happening 8 times, actually. So what I can do is I can put the exponent 8 up here, okay? And after I've done that, I have my equation. So I have my initial amount that is being increased by 1.02 times, only one time, but if I want it to be 8 times, I'll put an exponent 8 there, and I'll get my answer. And of course, with these questions, we're good to use a calculator. So when we put this into our calculator, we will get around $586. Okay, we can put dollars there. So after 8 years, we can see that we've earned $86, or we have a total of $586, which we haven't really earned too much money. But that is what our savings account give us. So that's what we're going to go with. All right, next one. It's talking about tweeting and Twitter. So your tweet's so popular that it actually reaches all 100 of your followers. Okay, so that's our one piece of information. It reaches 100 of our followers, and each day that our tweet is out there, it reaches 13% more people because of retweets and likes. So each day it reaches 13% more people. How many people have seen your tweet after a week? So this is a really good question. Let's think about it. So we have, again, some initial amount of 100. That 100, that 100, or each day, it is reaching 13% more people than these 100. Okay, and we want to know how much it reaches after a week. So after a week, or we can say 7 days. Okay, so again, very similar setup here. We have our initial amount of, okay, it reaches 100 people, and after it reaches those 100 people, each day going forward, it reaches 13% more people due to retweets and likes. And so what we can do is, again, we can multiply it by this 13%. Now, if we just multiply it by 13%, we want to change 13% to a decimal. So that is 0.13. If we just do 100 times 0.13, what that's going to get us is it's going to get us what is 13% of 100, which is great to know. 13% of 100 is 13. That's great to know, but what we want is we want to then add that whatever 13% of 100 is onto 100, okay? So instead of doing times 0.13, we're going to do times 1 plus 0.13. This is a similar concept as if you were calculating tax onto something. If something costs $100 and you want to calculate 13% tax on it, you just do 100 times 0.13. But if you want to add that 13% tax onto your $100 that you're already paying, then you would do 100 times 1.13. And that's just what we're showing here. This is just 1.13. So we're adding this 13% onto 100, which is what we want. And the question is asking us how many people will see our tweet after 7 days. So we put an exponent 7 here because this expression is just for 1 day. We want it for 7. Okay, and you put that into your calculator again, and you'll get around 235. So 235 people will see your tweet after a week. Again, another pretty easy problem, not necessarily too difficult. Now with this last one, this one gets a little bit more difficult, but again, we'll go over everything together. So let's see what it says here. Due to high demand, new houses are constructed by a factor of 1.09 semi-annually in an already existing neighborhood. Okay, after 7 years, there are 458 houses built. How many houses were there before the construction started? Okay, interesting. So what we have here is we don't know how many houses we're starting off with. We're already in an existing neighborhood. Okay, so there's some amount of houses in this neighborhood, and we know that the amount of houses increases by 1.09 semi-annually. Okay, so that's every 6 months or every half a year. After 7 years, there are 458 houses. So what we're actually given here is the end product. At the end of all of this building, we have 458 houses. But how many did we start with? Okay, so we don't know how many we started with, so we're going to write that as x. We started with some amount, some x amount, okay? And whatever that amount was, the construction, the amount of houses built after it, was increased by a factor of 1.09 semi-annually. So what we can do is type 1.09, okay, and it's happening semi-annually. And we know that after 7 years, there were 458 houses. So this 7 years is also useful. That's going to be our exponent. But this factor of 1.09 is calculated semi-annually, where this is not semi-annually, it's annually. So we either need to convert our factor of 1.09 semi-annually to a factor that is annual, or we need to change these 7 years into basically half years. Now, to me, it's easier to change 7 years into half years, and I can just see that 7 years is 14 half years or 14 semi years, which now matches up with this semi-annual factor of 1.09. So instead of having 7 here as our exponent, we're going to have 14. And we know that at the end of all of this building, we had 458 houses. So our answer is actually going to be 458. And what we want to find out here is, of course, what x is. This isn't too difficult, it just requires a little bit of rearrangement. We're just going to divide both sides by 1.09 to the exponent 14. 1.09 to the exponent 14. And on the left-hand side, it will, of course, cancel out. And all we will be left with is x equals 458 divided by 1.09 to the exponent 14. And if we do the math again, we'll get approximately 130 137. You're going to get a decimal, but we're just going to round down that decimal to the whole number. You can't have, half of a house. You need a whole number. So we get our answer of 137, basically telling us that before the construction started, right, we had 137 houses. So we started with 137 houses, and we built more houses at a rate of 1.09 houses semi-annually. And after 7 years, we ended up with 458 houses. Okay? So those are the three examples of kind of word problems with exponents. You might see other ones down the road. You might see other examples, but these are the three that we have today. And that's pretty much everything that we covered with exponents. Of course, I would still recommend that you practice your exponents and work on the negative bases, negative exponents, and the fractional bases and exponents. But in terms of word problems, this is all there is to it. So that's everything for this video.